Hello and welcome to my sixth video in my Part 4 Java MTA course. In this one we're going to be looking at the difference between a for loop and a for each loop. As always, I'm going to talk to you about the most important information needed for the exam first, and then we're going to go through some questions to make sure you really cement that information. So let's get started. So before we start talking about iteration and for each, you should have a good understanding of the selection statement. So this flow chart should make a lot of sense to you, where this is an if statement flowchart where you have the condition, and if the condition is true, then you execute this code. The most important thing about an if statement is what is the condition. So when creating an if statement, you have to think about only this question. However, if you start thinking about a for loop, the iteration, you actually have to think more than this one question. You have to start thinking about how many times do you want to check the condition. So for a for loop, with any for loop, you need to be able to answer these two questions. So for example, let's look at a real world example of where you might use a for loop. So if you're running around a racetrack, the action is running around the track, and you know that after 4 laps the race will finish. So you know how many times you will run around the track. 4 times. So if you know it before you start the loop, you know how many times you want this to go round. This is a perfect example of using a for loop. For a for each, you should think of it as a more festive for loop. So if you have a box or a group of boxes, and the action is going to each box and opening it, and then all you need to do is how many times you go round means how many boxes there are. So you only use the for each loop when you have those boxes to open it. You don't have it when there's another action. So if you're talking about just a general action, like running around the racetrack or completing this many activities, then you would want to use a for loop. But if you have a number of gifts that you want to open, then you would use a for each loop. If you think of it like this, then that would be very easy to remember, because then all you need to do is remember what would represent a box or a gift. And that is fairly straightforward, which we'll explain now. Okay, so we're going to have a look at how we can map our real world example of a group of boxes to Java. So this is the Java code. Do you remember we want to go to each box and open it up? And then when all the boxes are open, that's our condition. That's when we end it. And we know that there are, in this example, there are 3 boxes. So if we think of, in this code, we think of arrays as a box or a group of boxes. So that's a great way of thinking it. Arrays are a group of boxes. And then if we look at our for statement, the key word, we got the for, we have a variable, we have these 2 dots, and then we have our array. So the one at the end, this is our array. This is the group of boxes that we are passing into our for each loop. And then every time we open up one box, we're going to insert the values from that open box into this variable. So what happens in each loop is we open up one of the boxes and insert it into our variable. Now in this case, all of our values will be string, and that's why we need to create a string value, a data type for our variable. If we have an array that has an integer, then we will need to change this from string to int. Okay, so it's important that we have a group of boxes. As we loop round, each box is opened up, their value is then inserted into the variable, and then we can do all sorts of stuff with that variable. So in this example, we're just printing it out. And because we know how many elements there, or the computer knows how many elements there are in an array, we don't need to add any conditions, like any conditional statements to kind of saying when we're going to break the loop, because the computer already knows how many boxes we have in our array. So let's look at the example of the for loop. So we have the real life example, and then this is the code that represents a for loop in Java. What you notice is the for loop is a little bit more complicated, and that's because we need to tell the computer how many times it's looping round. and what happens after each time it loops round. So unlike the for each loop, the computer doesn't know how many times we want it to loop round, so we have to give it that information. So we have three sections. It needs three pieces of information. The first one, we need to create a counter variable. We need to create something that allows us to count how many times we've looped round our code. So for example, in this real world example, that counter would be like a man that's standing by the finishing line, and every time a person crosses it, it increases it by 1. And then the second one, this is a condition that tells us when when the code will loop. So as long as that counter is less than 10, it will keep looping round. So as soon as that counter is greater than 10 or equals to 10, this condition will be false, and then this will break. So the second part, or the second section, tells us when we break our loop. And then the third section, this creates the action that occurs after the loop has been executed. So once the loop has been executed, what do we do with our counter? So in this section here, what we've done is we've just adding that counter by 1 here. So that plus plus, it just means adding that by 1. If you are a little unsure about what that plus plus means, go back and have a look at one of my previous videos about how these assignments affects our videos, and you can see that in our playlist. But if you do know, it's just important that the third section is executed after the loop happens, and it tells them what are you going to do with that counter. The last and quite important piece of information is that even though I've done that counter here, usually this variable will be shown in most examples as an I, because this variable is kind of like a throwaway variable. As soon as this for loop is finished, you don't want to use it anymore. So in most examples, you won't see something like counter. You'll see something like I or E, something that's like a letter. So don't let that be distracting, or don't let that distract you in the examples. It's still counting the number of times it's looping around, and based on that counter, it determines whether it breaks or not. And then the third section, just for that counter variable, what are you going to do with it? How many are you going to add or change within that variable? Okay, so we have a code here, and the first question is you have to tell me if the expected answer is 345, what should go into the question mark here to get that expected answer. So let's have a look at the question, or first pause the video and try to answer question 1 and question 2, and then replay it and we'll hear the answer. So hopefully you've paused it. Let's go through them. So we know what our variable's name is because we can see it here and here in both the condition and what the action we have to do to that variable. So we know it's I. Now we also know that we're comparing in our condition a number, so that data type must be an int. So we know that it's an int, and the variable name is I. Now all we need to know is the value we start off with, because it doesn't have to start off with 0 all the time. In fact, because the outcome starts off at 3, we know that the initial value is 3. So if we put int I equals 3 here, what will happen is I, which is 3, will be compared to 5, and because it's less than 5, it will print 3. Then it will be added, 1 will be added because of this section, so that would make it 4. 4 then would be compared to 5, so 4 is less than 5, so it will print 4. Then 1 will be added, again because of this section, which would be 5. Here, 5 is equals to 5, so we'll print the last one, which is, we'll print 5 out. Then we would add it to 6. 6 does not equal 5 and is not less than 5, so we'll break. So if we insert int I equals 3 into this section, we'll get an output of 3, 4, and 5. Number 2, what would be the correct code? Well, the first one, there are a couple of errors in it. The first one, the first error, Those brackets are the wrong type of brackets. We don't want the curly brackets for our for statement. And then the comma is not used to separate the sections. So the comma is an error. So number A or A is wrong. Number B, we have not declared anything, or we've not initialized a value here. And secondly, more importantly, this value, this variable, is a string type. However, in the condition, we're comparing it with a number, so this wouldn't work. So B is wrong. If we look at C, we have the curly brackets, which is right. We've initialized and declared our variable, which is an int. We then have created a condition, but the problem is we've separated it with a comma. So even though the rest of it is correct, the comma makes this invalid. So the last one, we've created a value int y, and we've given it a 13 value. We're saying while this is greater than 10, execute the code, and then after one, we're using this y minus minus, and again this means it's just taking one away each time from y. Again, if you're confused with the plus plus minus minus, go back to my previous videos, and there is a video that explains this in better detail. So the answer is D. Again, let's have a look at question 3 and 4. Pause the video and see if you can answer the questions. So number 3, what is the output of the code? So we're saying 20 here. So it starts off with 20, and while 20 is less than 15, or while 20 is greater than 15, sorry, we execute the code. So we'll say we'd execute 20, and because we're doing print rather than print line, it will be all in the same line. And then after each one, we'll take one away. So 19 is less than 20, 18 is less than 15, 17, is greater than 15, 16 is greater than 15, and then 15 is not greater than 15, so it'll break. So we'll go from 20, 19, 18, 17, 16, and then break before it does the 15. Next one, how many times will hello be printed? Again, we've got our initial value set at 0, and it's saying while z is equal to 0, do this code. So then we'll print it once, and then it will add z and increase it by 1, so that would be 1, which means z is not equal to 0 anymore, so break the code. So it will only loop round once. So for the last set of questions, we're going to be looking at for each here. So what would be the output from this code, and what would be inserted into the question marks? Again, pause the video and see if you can answer these questions. So here, number 5, we have our boxes, and then each box will be inserted into our variable. But we're not printing all of the boxes, we're not printing all of our variables. We can then go into check to see if our value is less than 10. And if it is, we're going to print it. So here, which box is less than 10? Well, that's 2 and 8. So 2 will be printed first, and then 8 will be printed on the new line because it's a print line there. So the output will be 2 and 8. Next one, number 6, what would be inserted into the question marks? Again, if we look here, we have sentences, that's our array, and then we're going to put them into our variable. And if we look, we need to do a data type of that. So the data type must match the data type in our array, which is a string. So it can't be A and C. And then, so it could be B or D, but if we look at B, it's lowercase, and string has to be uppercase because it's a reference type. Again, if you're not sure about what a reference type is, it is important to know that for the MTA exam. So go check out that video about reference types in my playlist. But the answer is D. So we've come to the end of the video. If you are able to tell the difference between a for and a for each, I'd say you have a good understanding of the content of the video. If you can remember the 3 sections that you need to remember for a for loop, then you will be able to answer the majority of the MTA questions. And then if you are able to explain a situation when you can use a for each loop, it means that you can apply this knowledge in a real world example, and that's what we're aiming for. So that's fantastic. If you enjoyed the video or you thought it was useful, please like. And if you want more mock style questions for the MTA, please subscribe, because I will be publishing more as we go along. Otherwise, I'll see you in the other video.